This is Unit 5, Lesson 3, Day 5 homework, and this is question number 11, and we're looking at page 383 out of the Core Plus Mathematics Series 2, Course 3 text. And so I'm taking a look at writing each of these rational expressions as a sum or difference of two or more algebraic functions in simplest form. So looking at part A, we have 3x plus 5 over x, and we're going to take a look at turning this into a sum or a difference. Well, we have some freedom in doing this, but what I'm going to do is actually separate this out in terms of two fractions with one denominator. So I'm going to use this denominator here and write this as 3x over x plus 5 over x, which I could reduce then that this x over x would just become 3 plus 5 over x. I do want to qualify, though, that x cannot equal 0, but we know that from this part of the expression anyway. Okay? So there's the first part in A. Let's look at B. I have 3x squared plus 5x over x. I'm going to do the same thing here. Separate the numerator into its two parts over the same denominator. So it's going to be 3x squared over x plus 5x over x, which we could reduce to 3x. Now when I cancel one of these x's off, I don't have an x in the bottom. This is like 3x over 1 if we wanted to write it that way, but leave it as 3x. And then 5x over x, we'll just simplify it to 3x plus 5. Qualify it and say that x cannot equal 0. It's the only part it can't equal. Part C. Now we have 3x squared minus 9x plus 12. Okay. So we could do some factoring on this first if we'd like to. Oops, over 6x squared. We could try factoring first if we want to see if that changes the bottom, except that I know that the bottom is also not a linear factor either, so I don't really need to do that. What we could do is then separate this out into its equivalent fractions, three pieces, three fractions all over the same denominator. So I have 3x squared over 6x squared minus 9x over 6x squared plus 12 over 6x squared. And if I look at each of those pieces, 3 over 6 will simplify with leaving a 2 on the bottom. The x squared over x squared cancels off, leaving just 1 on top, right? And then over here, the 9 and the 6, I know a 3 goes in each of those, so I have 3 over 2. And there's an x on the square on the bottom, so we'll leave an x on the bottom. And then the last one, 6 goes into 12 2 times, but we have nothing to cancel off the x squared. So this is an equivalent expression. We also want to provide here that x cannot equal 0, but we know that from here and from here as well. So even though that 0 cancels out here, we're still getting some information about x cannot equal 0. All right, then part D. We have 3x plus 21 over x plus 7. What I'd recommend doing here is actually factoring first and making this 3 times x plus 7 over x plus 7. So then what we're seeing is that this cancels off, and this is actually equal to 3. But we want to say that x cannot equal a negative 7. Now, one thing you cannot do not do this. I'm going to write this on here. Do not do this. Don't write this as 3x over x plus 21 over 7. This is not equivalent. And we could put in a counterexample if we wanted to. So a counterexample to this would lead, even if x is 1, 3 times 1 over 1 plus 21 over 7 equals 3 plus 3 equals 6. But we know up here that we equal to 3 no matter what. And you can even put that up in the original one. 3 times 1 plus 21 over 1 plus 7 would equal 24 over 8, which equals 3. So these are not the same. 3 does not equal 6. So do not do separate the fraction and the linear portion of the bottom. We can only separate the numerator with all the same denominator. And the bottom here, when you have the denominator as x plus 7, that can't be separated into just x and just 7. We could if they were multipliers, but these are add-ins, not factors. So do not do that part there. And that ends question number 11.